Hello, everyone. Uh, Welcome to second part of the lecture about trigonometric integral. So for today, I only have 4 problems to solve. So let's get started. Our first problem for today is integral of sine cube of x cosine square of x dx. So looking at this problem, as we know that the derivative so d over dx of sine of x is cosine of x, and d over dx of cosine of x equal negative sine of x. So what I can do, as you can see that sine is to power 3 and cosine is to power 2. So what I can do is strip one of the sine and keep the rest. So what I mean is that I can write this integral as sine square of x, cosine square of x, and sine of x dx. So I will use this sine as a part that is a derivative of something, of some other term. So all I would need to do is increment the power of that term by 1 and divide by the new power. So let me show you what I mean. So the derivative of cosine is negative sine. So it would be better to convert this term into cosine of x. So as we know, sine square can be written as 1 minus cosine square of x. And the next term simply will come down here, and we have sine of x dx. So I can write all this as cosine square of x sine of x minus cosine to power 4x sine of x dx. So let's focus on this. Now, a derivative of cosine is negative sine. I already have sine, but I don't have the negative. So I can easily substitute for that. And this becomes cosine cubed divided by 3. Similar logic applied to here. The derivative of cosine is negative sine, and I already have the negative in here. So it becomes positive cosine to power 5x divided by 5 and add the constant. So that is the final answer. Let's move to the next problem. Sine to power 5. So as we saw in the previous problem, we can write sine in terms of cosine using the appropriate trig identity. So I can write this as integral of sine to power 4 of x sine of x dx. Then this become integral sine square of x to power 2 and sine of x dx. And now I'm going to use the correct identity, which is simply 1 minus cosine square of x, and the whole thing is square, and sine of x dx. And as you can see now, this term, it only has cosine, and derivative of cosine is negative sine. So let's continue. And let's see. It will become integral of 1 minus 2 cosine square of x plus cosine to the fourth x sine of x dx. Now I'll just distribute sine of x minus 2 cosine square of x sine of x plus cosine to the fourth x sine of x dx. So integral, let's take it term by term. Now integral of sine. What is integral of sine? And then the next term, we have cosine multiplied by sine. A derivative of cosine is negative sine. And same thing here, derivative of cosine is negative sine. So now it is in a form that we can integrate. So integral of sine of x equal negative cosine of x. And the next term, derivative of cosine is negative sine. So the negative becomes positive. It will become 2 cosine to power 3 of x divided by 3. And the next term is, because derivative of cosine is negative sine, I need to substitute for the negative, and becomes cosine to power 5 of x divided by 5, and then add the constant. So that is the final answer. I hope this is clear. As you can see, it's just a matter of modifying and using the right identity in order to get to the form that is convenient to integrate. Okay, our third problem, sine square of x cosine square of x dx. So as you can see, both are even power. So we need a slightly different technique in here. So we will use the double angle formula, which is basically sine square of x equal 1/2 1 minus cosine 2x. And similarly, cosine square of x equal 1/2 1 plus cosine of 2x. So let's substitute these two identities in the integral. Then I will have 1/2 1 minus cosine of 2x multiplied by 1/2 1 plus cosine of 2x, and I have the x. So it'll become 1/4, and simply this one becomes 1 minus cosine square of 2x dx. But 1 minus cosine square of 2x simply become sine square of 2x dx. And now we'll use the formula again. So 1/4 times 1/2 integral of 1 minus cosine double angle, which become 4x dx. So 2 times 4 is 8. Now integral of 1 is simply x. Integral cosine fourth of x simply becomes 1/4. I need to substitute for the angle. Sine 4x plus c. So that is the final answer. So it all matter of using the appropriate trig identity in the question, and also need some technique to modify certain functions to put them in a more convenient form to integrate. Okay, our last problem is this. Integral of square root cosine of theta, and that's multiplied by sine cube of theta d theta. So again, we know that derivative of sine is cosine and derivative of cosine is negative sine. So let's see, let's try to put this question in that form. So this one become cosine of theta to power 1/2. And I can write this one as sine square of theta, sine of theta, d theta. Again, I'll try to put all this in terms of cosine so that I will have the remaining term as sine, and derivative of cosine is negative sine, so that I can integrate. Substitution for a sine is easy. So it will become cosine of theta to power 1/2. Sine square is simply 1 minus cosine square of theta. And I have sine of theta here and d theta. So distributing this term, you will have cosine of theta to power 1/2 minus cosine of theta to power 5/2. And I have sine of theta outside d theta. Now, what is the derivative of cosine? Simply negative sine. So let's distribute the sign now. So we will have cosine of theta to power 1/2 sine of theta d theta minus integral of cosine of 5/2 of theta sine of theta d theta. Again, derivative of cosine is negative sine, so this one becomes negative cosine of theta to power 3/2 divided by 3/2. The derivative of cosine is negative sine, and I have the negative, so it will become plus cosine of theta to power 7/2 divided by 7/2 plus c. So that's the final answer. That's the last question that I have for today. I hope this was useful. Please like or share this video so that more and more people can benefit from this.